Hello and welcome to Rasa Chats, the Rasa podcast, where we talk about conversational AI, natural language processing related topics. And I am very excited today to be joined by Dr. Victor Dibia, who has like an insanely impressive career. You've been at IBM. You're at Cloudera now, right?
Yes, that is correct.
Yeah. Do you want to talk a little bit about what it is you do and your path and how you got into machine learning in general? And then I'm really excited to be able to just ask about your work because you do so many cool things.
Yeah. Well, first of all, thanks for inviting me over. It's kind of really exciting to talk to you on your podcast. I have followed your work, and so I remember I saw a couple of your paper reading sessions, and those were interesting. I think that was back before you joined Rasa. I think you were at Kaggle, something like that.
Kaggle, yeah.
Yeah, so that was good. So hi everyone, my name is Victor Dibia. I'm a research engineer focused on machine learning at Cloudera Fast Forward Labs. And for context, Fast Forward Labs was this little machine learning consultancy team. It was a startup about 5-6 years ago, started by Hilary Mason and then got acquired by Cloudera. And now it's a fairly small team, and we essentially focus on applied AI problems. As a research engineer, my role kind of has two parts right now. And so it's applied machine learning research. And so you might see that at our team with occasionally, I think right now we have like a quarterly cadence where we take a machine learning problem that's at this nice cusp of transitioning from academic research to things that customers can actually use. And we'll research this topic in detail. We'll write like a 90-page white paper. And we'll also build web prototypes that help kind of communicate or explain how these things work in practice. So help clients kind of understand what a product built with this technology could look like. So that's part of my role. And the other half has to do with helping some of our clients architect machine learning solutions and also contributing to our Cloudera machine learning product. And so that's like an overview of what I do right now.
I'm just going to quickly insert for the Rasa developers. Fast Forward Labs had a white paper on few-shot text classification that is super relevant to intent classification and conversational AI in general. So if you haven't checked that out, I would recommend it.
Yeah. And so one thing I should mention is that the work we do is sort of generalist. And so you might see that it cuts across multiple different areas. And so, for example, in the last couple of years, we've released reports that touch on topics like deep learning for anomaly detection, causality for machine learning, few-shot text classification, transfer learning for natural language processing. And so we are more of like an applied AI group. And so essentially some of the problems we will typically tackle will fall across computer vision, NLP, and time series data domains. And so I guess you also asked another question, what was my background like? How did I get into machine learning AI? And I could try to talk a little bit about that. My background is sort of multidisciplinary. And so what that means is that my bachelor's and my master's focused mainly on computer science, software engineering, distributed systems. And so I attended Carnegie Mellon University for my master's degree. And so I did a master's in information networking. And for my thesis, I spent time thinking through how to implement a method for identity-based encryption that my supervisor had introduced. And so he had written this nice paper around how you could use information unique to individuals like emails, phone numbers, and essentially build like an equivalent of public key cryptography system on top of that. And so it was supposed to be some sort of alternative to what we have right now with certificate authorities and all of that. And I did that thesis. It was super math heavy, and it was a lot of low-level software engineering. And one of the things I got out of that was that I really didn't want to spend too much time in that area. And so yeah, that tends to happen. And so after that, I took some time off, and I moved to West Africa, and so I'm originally Nigerian, and so I moved back there. And I taught at the university, and I worked at a startup. I started a little company that was focused on making applications for the African market.
Mhm.
And after that, I kind of decided, oh, while I'd spent a lot of time thinking about the technical aspects of software, I wanted to learn more about the user and the business part of things. So I
Mhm.
decided to do a PhD in information systems with a strong HCI focus.
Mhm.
And for that, I made a lot of interesting decisions back then. So I decided I wanted to do that in Asia. And so
Mm.
as at that point, I had lived in Africa, I had lived some in Europe, and I had studied in the US, and I'd never been to Asia. And as at that time too, there was this really strong information systems program at City University of Hong Kong. And so I ended up
Mhm.
deciding to study for a PhD there. And so towards the end of the PhD, I got the opportunity to do this nice internship with IBM Research. And I was
Mm.
with this group called the Cognitive Environments Lab. And the goal was that it was a strong HCI group. And part of our mandate was to collaborate with a machine learning group and start to build user experiences and prototypes that sort of take some of the APIs that IBM was creating. We were calling them cognitive APIs back then, and
Mhm.
building those things into products. And so that's sort of where my HCI work, my applied machine learning work really started. And so we started out with things like building out room scale experiences.
Mhm.
So you could imagine the person walked into a room and they could say things like, I need help with exploring, let's say, a database of exoplanets. And there were like microphone arrays in this room, and there was a really large screen that could show visualizations. And they were like pointing and gesture recognition infrastructure there too. And you could say things like, tell me about this data set, and you could point to things. And the task there was to find good ways of combining this sort of multimodal input, so voice and pointing and gestures,
Mhm.
to figure out the user's intent and then convert that to queries, show the appropriate visualization, and just build nice, smooth interactions around that. And I did that for a little while. We also spent some time building maker kits that help people sort of get familiarized with machine learning. So it was like Raspberry Pis, cardboards, chipboards, that sort of thing. And I did that for a couple of years, and then I joined Cloudera. So that's a high level overview of how I kind of got into this space. And I'm happy to talk about some individual projects in a little bit more detail.
Yeah, I was. I'm glad you talked about the I think cognitive assistant was the way that it was talked about when I ran into it, that whole room experience. So my background is very much just in language and
Okay.
NLP, um, and there's so much interest. Well, NLP and speech, but there's so much interest in really more multimodal experiences and assistance and incorporating all these different pieces of information. Um, and you really are at the inflection point between what's research and sort of impractical to actually do yourself, and then like, hey, you can do this now and here's how. So I would love to get your perspective on where you see the current state of research on multimodal assistance generally, and where you see things going in the near to medium future. And third part of the question, what advice do you have for developers who are working in the space? Like if someone's working on just text right now and they're interested in maybe adding voice or vision or gesture modeling, what to
Right.
do next?
Right.
So little question.
Yeah, absolutely. And so just for the benefit of the listeners, this work I referenced around multimodal interaction, this was sometime in 2016. And in machine learning time, it's a really, really long time. And so a lot of things have changed for the better for the most part. And back then, speech to text didn't work nearly as well as it does now. It was a huge problem. So that's one of the things that will drive us really, really nuts. Would have these long conversations and would expect to have this nice transcript that we could work on, and half the time the system just got it wrong. And the other thing was also when you issue verbal commands, that entire system is super bottlenecked on the quality of the transcriptions. And so, the system can only react to the extent to which it sort of translates it correctly. And back then, one of the things we had was that we always had these visual interfaces where on the minimum we were visualizing the transcripts and attempting to visualize the sort of commands or resolutions that the system was making based on the commands you gave. And so that sort of visual feedback, at least it helped people understand when the system was failing. It gave them cues on how to either try to repair the conversation, reissue commands and all of that. And so that was how we try to address those failures. I think as of today, I think speech recognition is a lot better. And so it's a much more interesting time to do that sort of multimodal work and have a little bit more confidence that your system won't have all these random failures. That's number one. The second thing back then was that for a room scale experience, the room we had was essentially it was outfitted with a lot of equipment, and so we had microphone arrays built into the ceiling, so that the user could issue commands that would get like high resolution capture. In some cases, the person communicating with the system would wear a lavalier, so it's just a mic, a headphone microphone, and we also had a 3D pointing device. And so it was some custom built system by the company. I think if I recall correctly, the company that helped prototype the whole, there's this famous movie with Tom Cruise where he has this hand gesture interaction space where he's interacting with a bunch of things. I think the company that helped prototype or imagine that whole experience, they actually have like some really high quality 3D triangulation pointing device that allows you to point in 3D space. The point of all of this was that for our demo to work well, we needed all of this custom hardware. And that's one thing that really, really limits the practical use of this sort of technology, because all of this equipment is not exactly portable. And so the lesson here is that for systems like this, multimodal systems to work really well, they have to have just a really, really small footprint for hardware requirements. And so I think two things that have changed between then and now that make this space really, really interesting is the fact that speech to text is a lot better now, and so you can rely on speech to multimodal interaction. The second thing is there's been a ton of advances in computer vision. So essentially, a lot of the things that you needed 3D signals for, so depth sensors and all of that, 3D pointing devices, there's a good chance that you can do all of that now with 2D images. And so you can now extrapolate from 2D images to estimate depth and all of the other data that you would actually need a bunch of custom sensors for. And so I think now with all of those, I think now is a good time to start to revisit this sort of speech and pointing and gesture-based interaction. Now is a good time to revisit. I haven't done that a lot of it recently, even though I've spent a bit of time doing things like hand tracking from 2D images, but I haven't spent a lot of time. So I think it's a good space to be in. So using current like open source implementations of 2D to 3D mapping, and also open source speech to text software, definitely it's a good time to kind of revisit that space.
Definitely.
Did I miss any questions? Sorry.
No, I think you hit my like insane. It wasn't insane. It was just very complex, multi-part question. Yeah, and I was, as you were talking, I was like, oh yeah, because like all the like AR gesture recognition stuff would not have been around back then. It was even today I saw a paper. I haven't had a chance to read it yet on unsupervised training ASR systems in an unsupervised way that without labeled text data is doing about as well as we were using labeled text data 2 years ago on novel languages, which is such an exciting time to be in the space.
Yeah, that's the paper from Facebook, right?
I think so, yeah.
Yeah,
I just have it bookmarked.
Yeah, I saw that today. I haven't read it. It's exciting. Like I said, 3 years, 4 years in machine learning time is a really, really long time. 6 months can be a really, really long time. So it's super cool. There's so much stuff to try. I've almost lost hope on being able to go through all the list of experiments I really want to dig into. So yeah.
Oh, I guess the nice flip side to that for folks who are new to the field is that you're likely to be able to find something new that you can do that probably no one has had time to do yet.
Yeah.
So that's the nice corollary.
Yeah, absolutely.
And I love the point you made in there about when there is a point in the system where there might be a failure on the system's point that might cause problems down the line. So I think you gave the ASR example, giving feedback about what the system understood so that the users understand where the problem is. I think it's a great point and a really good way to help avoid user frustration. Let's put it that way.
Yeah, absolutely. So I completely agree with that point. And now as part of my job, we build prototypes, and I feel, part of the things that my HCI background kind of helps me think through is the user experience for machine learning like powered products. People tend to always, developers tend to, when they build machine learning systems, they tend to focus the most on just spending a lot of time making sure that your model, it has good evaluation scores and some test metric. And then you might put in a little bit more effort to make this thing available through some API, and then you spend the smallest amount of effort just putting some interface on top of it. My thinking and the way I always encourage others who I talk about this topic with is that maybe it might be a good idea to spend a little bit more time optimizing the user experience on top of machine learning models, because there are all these sources of challenges for users that really can interfere with the adoption of your tool if you don't put that much effort into that. And so it's things like finding ways to sort of clearly visualize what the model is doing and help the user build intuition on what are the failure modes or what are the capabilities, when does it get things right and when it doesn't, communicate that the model is failing such that they can make alternate decisions as needed. Right.
Yeah, I think that's a great point because I don't know, I think a lot about the differences between machine learning engineering and other types of software engineering. And like one of the things that is just true about building machine learning systems is that you are not going to build an infallible classifier. Like it's just not going to happen.
Right.
Your system will fail. How do you communicate that? How do you maintain user trust and be transparent with them and like treat them like, people with agency and ability and
and sometimes the solution is to show things like confidence values. Say, I think it's gonna rain today, but I'm 92% confident. Sometimes that's helpful. Sometimes it's not as helpful as it could be, because sometimes the model, the user doesn't know, is 92% really, really good. Is 95% good. At what point should I be comfortable? And so sometimes as a designer, or as a person creating the interface, you might want to make some some other high-level abstractions, put some other high-level abstractions on top of that, like maybe say, instead of saying given a number, you might say things like very confident or medium confidence or not confident at all. And so this sort of buckets or labels are probably easier for the user to interpret and work with compared to just giving raw numbers or showing complex charts that actually require even more expertise to interpret. So it's a fine dance.
Yeah, it is. And I think that we're also sort of as people who are building systems, we know that the systems will fail and how they're likely to fail. But from the user standpoint, I know there's a public perception that, this AI system, the AI is infallible. It's seen so much more data. Of course, it's not going to make a mistake. So being able to, clearly communicate and be like, this is more like a dog that we've trained to sniff peanut butter than like a food inspector that's able to like identify the cause of peanut butter. I don't know.
Yeah. So that reminds me of an interesting story I had once. So I think sometime towards the end of 2016, I was with IBM, and one of the high-level goals that we had within our group was to help drive the adoption of our cognitive APIs. And so these were things like speech-to-text API, image classification APIs. And so essentially you'd essentially pipe for the speech-to-text, you pipe your audio through to the API. And so over a socket, it will return a bunch of live text transcription. And for the image API, you'd send an image and it'll return like a bunch of either a list of text within the image or tags for the image. And to help drive that, essentially what we're targeting was technical users, but who had almost no experience with machine learning. And so we sort of came up with this idea of maker kits. And so we came up with this kit called a TJ bot. And it came with a chipboard design. So it was a 3D printed or a laser cut chipboard that you could fold. And once you're done folding it, it will be in the form of a humanoid robot. It was really cute. And you could fit a Raspberry Pi inside, and it came with like a little servo motor arm and a camera and a microphone and an LED sensor. And we had built this Node.js library of sorts, super high level, had a couple of nice methods that you could do things like tjbot.listen, and essentially it was set up the whole like audio to text, and tjbot.speak, and you'll do speech to text, and tjbot.see, and it'll do like describe whatever the camera could see. And one of the first things we did was that whenever we put this in front of people, so we were doing like user studies, user tests, just to understand how people think of it, people would drastically overestimate what this bot could respond to, the sort of conversational turns it could engage in. And of course, we also had this dialogue sort of system where we had this pre-designed dialogue tree, and people would want to go off script all the time. And then the other hard part was that sometimes they also didn't know if the robot actually heard them correctly or if it had misinterpreted what they said. And so one of the things we did to fix that was that we then built this visual interface where as you interacted with the bot, everything the bot did, there was this nice visual interface where it will show exactly what it thought it heard you say. How it resolved that to some intent, the response it was given. If you told it to take a picture, it'll show that picture. And once we paired that with the thing they were interacting with, people started to act a lot differently. And they're like, wow, this thing is not so smart. Here are its limits. Here are the different things. I remember someone once put up a key in front of the robot and said, oh, what is this? And it gave some vague description. And then the person took a look at the picture the bot had taken and then said, okay, let me try something different. And he went and took a sheet of paper and put behind the keys. And then he said, what did you see? And then he said correctly, saw a key. And it was nice to see that, he had figured that it's possible that, background information and license conditions were sort of interrupting with the bot's ability to really respond to his query. And he was finding strategies to sort of make the problem easier or rephrase the problem such that the system could answer. And so that was like a really interesting example for us of how like interfaces that sort of allow the user to peek into what the machine is doing really can help them design better interaction strategies with this machine. So, okay.
Yeah, and it's, I work on dialogue systems, so that's always what I'm thinking about. But particularly with conversations, just to speak to the point that you made, we're used to having conversations with people, right? So our expectations about the degree of things that we should be able to say and like how it should go is really based on our experience with people who are, flexible and smart and like share a communication system. And making sure that your users understand the limits of the system they're interacting with, prevents frustration and makes it more useful. And decision making and software tools. I know that's one of your research areas, and I know not all of our listeners are building software tools, but we are, right? That's part of what we do at Rasa. So I was wondering if you'd like to talk about your work in that area a little bit.
You mean software tools, just maybe libraries in general, for the most part?
Yeah, okay. Whatever makes sense to you.
So, if I look over the last couple of years, I think I can categorize my work, especially my research-focused work, in two broad areas. And so, especially ones that are related to HCI, that intersection of HCI and machine learning. And so I can categorize them into two broad areas. And so one is tools that help make machine learning more accessible. And so it's this whole effort to recognize that there are a lot of people, many of them have technical backgrounds, but they just, it's still a bit of a struggle to build intuition on how machine learning really works. Yeah. And that space is really, really large. I know there's been a huge amount of really, really good work to sort of democratize machine learning. And so it's like really, really good libraries, all of the work in explainable AI, and so interactive web applications that help make AI, to some of the work we've done in using things like maker kits to make machine learning more approachable and socialize it among developers. And so I think this is an area that deserves a lot more attention. And so just tools, and so there's a lot of students, entry-level data scientists that would benefit from all this work. And so that's one of the things that my work has focused on. And I'll talk about a couple of projects that fall under that area. I think the second one has to do with finding ways to apply machine learning to make user interaction better. And so in the first genre, there's this tool that I've worked on, something called ConvNet Playground. And so I think we released that about two years ago. And it was kind of born out of the fact that during our work, when we would interact with, let's say, potential clients who we were sort of helping architect machine learning systems, they typically had a couple of questions. And so, for example, if you were looking at the problem of semantic image search or content-based search, the developer has a couple of choices. And so you could do things like use a pre-trained model to extract representations for every item within your catalog. And at test time, when you had a new query, you would extract a representation for this query. And then you look through your catalog to find essentially all of the items in your catalog that are most similar in embedding space to your query. However, to do that, you need to make decisions on what architecture do I use. Even when you selected an architecture, do I use the entire model? Do I use submodels or intermediate layers? And even when I do all of that, what distance metrics might make sense for that? And so making these decisions, I mean, for experienced machine learning engineers, it might be straightforward, but for kind of new users to the field, they need ways to sort of build intuition and sort of reason through, if I made all these decisions, what might the results look like? And that's kind of what ConvNet Playground does. And so you could, we have like 2 or 3 data sets that have specific properties, and we've pre-computed what the results would look like if you made all these different choices. And you could go and select an image, and essentially you could choose one of 8 pre-trained models. And for each pre-trained model, you could use one of 8 intermediate models as a feature extractor. And then you could, as you made your selection in real time, it would show you what the search performance looked like. And in addition to that, if you're going to select earlier layers versus later layers, of course, it's, you would make this decision if you knew what sort of representations each of these layers would give you. And so if you actually looked at the visual visualizations of those intermediate layers, you'll see that earlier layers focus on high-level features like color, texture, shapes, lines, while later layers focus on high-level concepts like, let's say, eyes or the side of a car, wheels, these sort of things. And so depending on the data, some of these features might be more relevant than others. And so ConvNet Playground sort of gives you this ability to look at these layer visualizations and then the impact of all these other choices. And we found that in our work, talking to clients, having them work with these examples can be a really great way for them to build this sort of intuition. And so that's an example of one way in which we can make AI or machine learning more accessible. And the second area is kind of focused on how can we use machine learning to build better interactions. And so one of my favorite applications of AI is the smart reply within Gmail, and also smart autocomplete. And so you start to type your email and it will suggest, like, let's say 5 words ahead, and you could press tab to either accept or reject that. I think it's just a really, really nice feature that makes the email authoring experience a lot better, a lot easier. Of course, it has its downsides. It has its downside, but I find that useful. And the reason why it's useful is that to some extent, it reduces the cognitive burden for the task at hand. And so a couple of years ago, one of the things I was thinking was, can we do the same thing for data visualization? And so we all know that, data visualization is kind of cool because visualizations are a really great way to summarize insights within really large data. However, many people just don't have the skills to author good visualization. So they either don't know the right encodings to choose, they don't know the right fields to use. And even when they choose fields, they're not sure what transformations do I apply to these fields. And in some cases, how do I write the code to generate these visualizations? And so the thought was, if they uploaded their data, can we have a model that suggests a bunch of, let's say, 5 visualizations that might make sense for that data? And so rather than, and also generate code for those visualizations, so that instead of just creating a visualization from scratch, they could either select one of the visualizations we suggest, or they could just modify those visualizations to fit their goal. Because the truth is, everybody comes to visualization with their own intents. It's very hard to predict that correctly. And so just find good ways to make the experience lighter and easier for users. And for that problem, you might be interested in it because we sort of formulate it as a language translation problem. Yeah. And that's one of the interesting things. And I think that was the main contribution of that work, because the thought is, like, how can you cast like visualization generation as a machine learning problem? Do you learn from raw data? Do you learn from images of existing visualizations? How do you cast this as a problem and then apply machine learning? And the path we sort of chose was to represent data it's essentially data. We can represent our data as text, so JSON lines of text, and we can represent visualizations also as text. And so there's this, I don't know if you're familiar with Vega Lite.
Mm-hmm. Yeah.
Yeah, so it's this nice declarative specification of visualizations where you can specify complex visualizations with a small amount of JSON text. Mm-hmm. And the goal is, imagine that we had a model that could take in, let's say, a couple of lines from a database or a data set. And based on that, it will generate Vega Lite visualization specifications, valid Vega Lite visualization specifications that make sense for this data. And so in this way, we can map, structure this as a sequence to sequence translation task where the input sequence is JSON data from your samples from your data set with some transformations. For example, might replace field names with canonical or text tokens. And then we just focus on generating valid Vega Lite specifications. And so this was the thinking, and we did a bunch of experiments, and it did work well. And so we used stacked bidirectional RNNs with attention. And so this was a couple of years ago. I'm sure there are better ways to do that now. And we showed that, these models can learn to generate perfect JSON, and not just that, also generate JSON that is faithful to the Vega Lite syntax, and so it compiles correctly. Wow. And so this sort of approaches can sort of make, like, let's say, visualization authoring just a tad bit easier. And then there's this other project, HandTrack.js, where the goal is to allow developers add 3 lines of code to their JavaScript application, and suddenly they can track hands and build all these creative hand-based interaction prototypes. Mm-hmm. So this turned out to be a long rant, but it's something I'm really excited about. And so these are a couple of projects in this whole area of making ML accessible and also making better interactions using machine learning. So I think it's a super fun area, though.
Yeah, it is. And I think that's I think there's a lot of need. Well, I don't know about need. Desire for tools that make repetitive processes easier, and machine learning can work really well for that. I'm reminded of when you mentioned you're using machine learning translation. I think it was Adam Lopez, who's the director of research at Rasa, said something like sequence to sequence is eating the world. Everything's sequence to sequence now. And it really is. It's a very broad approach.
Yeah. And I mean, as long as you can represent stuff as sequences, and you do have the right sort of data, there's a chance you could get a sequence model to do some really magical things. We weren't sure it would work, to be completely honest. We really we really weren't sure it would work, and then we ran a bunch of experiments, and we're like, oh wow, it's definitely promising. And of course, it had failure cases. And so there, of course, when you implement this thing in practice, I think in about 5 to 10% of all our trials, it would there are 2 problems. So first of all, in some cases, it will generate like JSON that did not compile well. The Vega Lite compiler just couldn't compile it. And then in some other cases, they would use this thing called phantom fields. So you will pull out fields that are not try to use fields that are not in the original data set. So called the phantom field problem. But in practice, what you would just do is you would run multiple samples till you get something good before you show that to the user. And so just like heuristics and fail-safes that just guarantee that the user experience is good, even when the model needs a couple of tries. It's a probabilistic model, so you try to find ways in software to account for that.
Yeah, I think there's 2 good pointers that everyone can take from that, and that's that point we made earlier, that like if you're using a machine learning approach, it will fail sometime. Know that. Expect that, and also that using heuristics, using rules as part of a system can really help catch things that you know are going to come up and get ahead of them and, make sure they're not a problem.
Right.
Yeah.
Just to make sure that always have like some heuristic system on top of your machine learning system to catch failure cases that you're aware of. Just to make sure that you can maintain good user experience. So, good point.
And user trust, if there's a repeatable problem and the users notice it, also probably you should have noticed it at some point. And maybe if you didn't, it's time to rethink your how much time you spent working on UX and UIs.
Yep.
To bring up the point you made earlier. Well, we're getting kind of close towards the end of our time, and I don't want to keep you too long because I'm sure you are fantastically busy. But is there anything you would like to pitch, or you'd like the Rasa community to know about, or just things you want people to think about, or anything you want to share, anything at all?
I am super excited about open source projects. It's nice to do. It's a little hard because you need to maintain it, but it's a great way to sort of contribute to the community. And in the machine learning space, I think it's a really generous community because a big part of the research people do, they make it open source. And a ton of the things I've learned, a ton of the things I've done is because of all the wonderful things everybody's done. And so, I guess, for any listener who is super interested in machine learning, just working in open source projects is just a great way to learn. I found it to be super, super helpful. And and if anyone was interested in talking about machine learning, AI, and HCI aspects of that, oh, he's so cute. Feel free to reach out on Twitter. If there are any of my open source projects that you think are interesting, feel free to reach out, talk about them. I'm always looking for people to collaborate with, which is nice. I'm currently working on a new version of HandTrack.js, which sort of significantly, essentially, it's a whole new model under the new version. Has smaller weights. There's all these new things in quantization, and right now it'll be nice to collaborate with anyone who's interested to sort of make that better. So, yep.
I know some researchers in gesture and sign language that I think will be very interested.
Sure, absolutely.
Well, thank you so much for joining me today. I really enjoyed our conversation. Thank you to the Rasa community for tuning in. I hope you also learned a lot, and definitely check out some of Victor's projects. He's got a fantastic website with links and stuff, and also Twitter. And your Twitter, I'm going to double check so that I say the right letters in the right order and not something else. It's VYKTHUR.
Yep.
On Twitter. Yep. Thanks so much, Rasa folks. Stay tuned for our Speaking of Open Source contributor shoutouts for all our new contributors. And I will see you in 2 weeks. And to round out our episode, I want to give a big shout out to all of our new Rasa contributors for your support and code contributions. We're delighted to have you. As always, if I mispronounce your name, please contact me and I will correct it in the next episode that I host. So without any further ado, big shout out to Nick, Barry, Erica Banderia, Marta Seca, Tobias Haas, Raja Durasingan, Vittorio Banfi, Stefan Kojo Harav, Joao Pedro Gomez, Ashwin Swarup, Belkis Bakar, Bujar, again, I'm sorry if I'm saying it wrong, Bakyu, and Sahib Singh. Thank you so much for your contributions. We're delighted to have you as members of the Rasa community, and we look forward to seeing what you do in the future. Have a great couple weeks, and we will see you next time on Rasa Chats.